Hello friends, welcome to my channel Physics with Rakshi. In the present video, we will see fifth chapter of the book Look Quantum Gravity for Everyone, authored by Rodolfo Gambini and George Pulling. In this chapter, first of all, we will see some basics of thermodynamics. Thereafter, we will see concept of black hole entropy, Bekenstein entropy, Hawking radiation. Thereafter, we will see black hole thermodynamics. Thereafter, we will see calculation of black hole entropy in loop quantum gravity, how theorist or physicist eliminates singularity in loop quantum gravity. So let us start. In thermodynamics, any system has two kind of states, microstates and macrostates. For instance, macrostates means overall property like temperature, pressure, volume, etc. Microstate means specific configuration. For instance, if we consider molecular gas, specifically in Avogadro number, there are 10 raised to 23 molecules in that system. So we cannot keep track the actual states of this system. So we have to consider macrostates and microstates in thermodynamics by considering statistical mechanics. So this is the first concept that we require to study quantum gravity. Another thing is entropy. Earlier in my YouTube channel, many times I discussed various definitions of entropy. Entropy, in general, entropy means measurement of randomness or disorder. Another definition is loss of energy to do work is also entropy. And in this context, entropy means measure of ignorance or incomplete information that we have is known as entropy. In closed system of thermodynamics, sometimes we cannot keep track the whole physical process of thermodynamics. So we have measure of ignorance, magnitude of ignorance. The more magnitude of ignorance we have, the more entropy the system exhibits. It is simple, just simple meaning of entropy in information theory, as we are talking about incomplete information or measure of ignorance. So in thermodynamics, there are three laws. Zeroth law is related to equilibrium. First law is related to conservation of energy. And second law, which is very important, that we require in this discussion of chapter 5, that is application black holes, is entropy either increases or remains constant no matter what you do in physics. So what happens now, by unifying thermodynamics with the physics of black hole, we can have new branch, that is black hole thermodynamics. First of all, what is black hole? We know that black hole is a kind of object whose gravitational pull is so intense that even light cannot escape from the event horizon of black hole. So regions whose gravitational pull so intense that even light cannot escape. For instance, any object which want to go out from the Earth's gravitational pull has to reach escape velocity or escape speed, that is 11.3 kilometer per second. And by this way, various space agencies have been launching various satellites, space shuttles, and various space missions. But in case of black hole, even light cannot escape from event horizon. Its escape velocity is infinite. So we cannot discuss escape speed in case of black hole if any object reaches to event horizon or inside the black hole. So inside black hole, no object can go out. Those objects that reach inside the black hole or up to event horizon. According to Einstein's special theory of relativity, speed of light is constant. So in 1915, Einstein gave is another version of theory of relativity, that is general theory of relativity, to explain gravity and to explain the flaws of Newton's gravitational theory. But here the thing is that even Einstein couldn't understand such kind of weird object that we call black hole in his theory, as it introduced infinity in equation that Einstein called field equations of various gravitational, what you call space-time geometries. Thereafter, in 1960s, Schwarzschild came up with first solution of Einstein's field equation, which is known as Schwarzschild metric, in which he considered static point-like object whose whole mass is concentrated on the center with spherical geometry, and that we are calling it black hole. But another thing is that as black hole, even light cannot escape from the event horizon of black hole. How can we observe black hole? This is the intriguing question in physics. So black hole creates effects in their surrounding through which we can observe its presence in space-time. Many black holes get matter dumped on them by a nearby star, and such matter settles quickly via collisions into accretion disk like Saturn has. So black hole's gravity heats up matter and converts into light, and we are observing this light, and by observing this light we can say that black hole is there at particular region of space-time or particular region of this astrophysical space-time or geometry. Event Horizon Telescope is dedicated to observe black holes' light. And LIGO, that is Laser Interferometer Gravitational Wave Observatory, have been observing gravitational waves which are coming from the collision of various black holes from distant space-time. So how can we characterize black hole? By three properties. There are three properties of black hole: mass, angular momentum, and charge. By studying this property, you can say that whether this black hole is any kind of or other kind of. Another thing is how black hole is created. Black hole is created by stellar or galactic collapse. When any star runs out of its fuel, it shrinks under its arm gravitational pull. In star, we know that outward radiation pressure balances inward gravitational pulls, and that is why star stabilize itself for several million years, like our sun. But when nuclear fuel of star is exhausted and star runs out of its fuel, star will be shrunk under its arm gravitational pull, and what happens, it will be converted into various phases of stellar collapse, like initially right from nebula to dust cloud, globule, protostar, brown dwarf star, main sequence, red giant, white dwarf, black dwarf, supernova, neutron star, and black hole. So these are the phases of life cycle of star. Those who are interested to understand these all phases can see my video on life cycle of stars in my YouTube channel. So by this way, we can understand how black hole is created in stellar or galactic collapse. And thereafter, Bekenstein in 80s came up with one analogy in which Bekenstein proposed that black hole's surface area is associated with its entropy. Like in thermodynamics, entropy either increases or remains constant. In black hole thermodynamics, surface area of black hole either increases or remains constant. So I can say that there is a 1-1 correspondence between surface area of black hole, and entropy. And thereafter, another thing is black hole's area is grown when it interacts. As because of interactions, what happens? Black hole will have more randomness or disorder, so it will have more entropy, and by this way its surface area is grown, and we can say that its entropy also will be grown. So by analogy of thermodynamics, there are three laws of black hole thermodynamics, like zeroth law of black hole thermodynamics, which is associated with surface gravity. Here there is a one-one correspondence between surface gravity and temperature. Thereafter, first law of black hole thermodynamics, which is analogous to first law of thermodynamics. Second law of black hole thermodynamics, which tells that either black hole's entropy or surface area increases or remains constant. That I have also discussed in one lecture on solution of black hole information paradox in loop quantum gravity in my YouTube channel. Those who are interested can see that video. Thereafter, Stephen Hawking came up with one new proposal regarding black hole. He studied quantum effects outside the geometry of event horizon, and he told that black hole is not totally black, rather it emits radiation which is known as Hawking radiation. He also gave one mathematical relation, that is black hole's temperature is inversely proportional to its mass. It means that if black hole's temperature increases, its mass will be decreased. So we can say that eventually, because of emission of radiation, black hole shrinks, and that is why its mass decreases and it will have more temperature, and ultimately it will be completely evaporated, and that creates information paradox or black hole information paradox, which is one of the unsolved problem in theoretical physics. So here I mentioned that there is a one-one correspondence between surface gravity and temperature, and one-one correspondence between entropy and surface area of black hole. In previous video, we saw that how any surface gains area by piercing various spin network lines or quantum states of spin network lines. We can have area. So we will start with that point. In LQG, a surface acquires area by piercing and spin network lines of quantum states which are corresponding to given space-time, the surface which is in. So in this diagram, I have shown that a given area of horizon can be realized by different spin network pierces through it. As here we are talking about quantum mechanics as well as general theory of relativity. We don't know which exact quantum states of spin network line will give us exact surface area of black hole in loop quantum gravity. We have to consider probability or sum over geometry, like sum over integral of Feynman's approach. So here different quantum states of spin network pierce surface different way, and that is why in the end we have to consider aggregate result to get consistent and tractable results, mathematically tractable results. So when we talk about a horizon of a given area, we don't know which quantum state is given rise to it. So it is the level of ignorance, and it gives us the concept of entropy of black hole. If we can completely keep track the quantum states of black hole in loop quantum gravity calculation, it means that its entropy is completely zero, which is impossible. Whether we are talking about quantum mechanics, whether we are talking about general theory of relativity, whether we are talking about quantum theory of gravity. So the more level of ignorance we have, the more entropy we will exhibit in case of black hole entropy calculation. Thereafter, various theoretical physicists in loop quantum gravity calculated black hole entropy in loop quantum gravity. In previous video, I told that mathematics of low quantum gravity is consistent, but how to test it? We have to apply this mathematics and physics of low quantum gravity in established classical concept of physics, whether it is relevant or not. So first theoretical signature we received by black hole entropy calculation in low quantum gravity. First of all, Carlo Rovelli and Krasnov calculated black hole entropy in loop quantum gravity. That we will discuss in separate videos that I will cover in my YouTube channels. Thereafter, Ashtakar, Korichi, Krasnov, Baez also came up with calculation of black hole entropy for different kind of black holes. Here, each time these physicists considered different kind of black hole in particular condition for particular limitations. There are some limitation, mathematical limitation also. Here we have to consider sometimes static black hole without charge and angular momentum. Sometimes we have to consider black hole with charge, sometimes black hole with speed. So there are different cases. Here thing is, in each calculation, there is a presence of one free parameter, which is known as Barbero immersive parameter in calculation of black hole entropy in loop quantum gravity, which tells the consistency, mathematical consistency of loop quantum gravity. And those who wanted to know more on immersive parameter can read my longest review article, which is published in Physics Journal. That is Barbero immersive parameter, enigmatic parameter of loop quantum gravity. In that article, I described immersive parameter deeply with all basics that requires. So there is a one free parameter, that is immersive parameter in calculation of black hole entropy in loop quantum gravity, and it presents in every calculation of these theories. So it tells the consistency of loop quantum gravity. So black hole, we know that in black hole, the whole mass of black hole is concentrated at the center of black hole, which tells that its volume is tends to infinite, and that is why its density is its volume is tends to zero, and that is why its density is tends to infinite. In classical physics or in general theory of relativity, this problem is occurred as we haven't considered Planck units, which sets cutoff on volume. For instance, in quantum gravity or in Planck units, cutoff value for volume is 10 raised to minus 105 meter cube. So here we are setting cutoff on volume, and that is why black hole cannot exhibit infinite density. And by this way, and mathematics of quantum gravity, which is complex, as I mentioned, we can ignore or we can replace singularity or infinity, which is occurred in black hole calculations. And by Big Bang's model of loop quantum gravity, physicists replace singularity by these models. Here, Big Bang model is replaced by Big Bang, in which singularity is totally removed by this calculation and Planck units. So elimination of singularity for static black hole is studied where it is replaced by large region curvature through which one can pass into another region of space-time in future. In loop quantum gravity, there are some objects which are theorized, like remnant scenario is one paper in which black hole is converted into white hole through one region or one tube. And another object is Planck star, which is located at singularity point. When black hole makes transition into white hole, it goes via Planck star object. So as I told, as temperature of black hole is inversely proportional to its mass, eventually black hole evaporates, which tells that whatever information is there inside the black hole will be completely lost, which is impossible according to principle of unitarity of quantum mechanics. Actually, from progenitor star, we will get black hole, but during these states, we cannot keep track whole characteristic of progenitor stars. This is what is we call level of ignorance. But after evaporation, whatever is information is there of progenitor of stars, like its spin, mass, angular momentum, dust, and fluids, etc., will be completely lost because black hole is completely evaporated. So it creates black hole information paradox. But here in loop quantum gravity, some theories like remnant scenario, Planck star can avoid and can replace such kind of weirdness from theory by giving consistent mathematical and physical concept that I will discuss in separate videos, and I have already discussed in one of my lecture of doctoral thesis, that is one preprint solution of black hole information paradox in loop quantum gravity. Those who are interested can view my that video in which I have discussed remnant scenario and Planck star with more depth. So what happens? Eventually black hole evaporates through slow process. We know that here in local frame process, because of time dilation, it requires many years to observe it. So that creates information paradox. Because of principle of unitarity in quantum mechanics, we can say that information is always preserved like energy. So by these theories like remnant scenario and Planck star, we can replace singularity, or we can remove singularity in infinity, which is occurred in black hole physics. So loop quantum gravity is, that is why, very consistent, elegant, and beautiful theory which has bright future in quantum theory of gravity. In this diagram, I have shown big bounce model in which, first of all, because of collapse, we will reach here where Planck star is located, and by this region, all mass will go outward and we will have white hole. So this is one cycle. In loop quantum gravity, Big Bang is replaced by big bounce model that we will see in next chapter of this book, that is loop quantum cosmology. So in this lecture on application of black hole in loop quantum gravity of chapter loop quantum gravity for everyone, we discussed fundamentals of thermodynamics, which is required to study black hole thermodynamics and black hole entropy calculation in loop quantum gravity. Thereafter, we saw some fundamentals of general theory of relativity, some fundamentals of black hole physics, fundamentals of black hole thermodynamics, how in loop quantum gravity physicists calculated entropy of black hole by considering quantization in loop quantum gravity. Various physicists gave calculation for black hole entropy by considering different kind of black holes. Here, this calculation, I want to mention that this calculation is limited for limited property of black holes. Till today, physicists haven't calculated complete black hole physics in loop quantum gravity, as loop quantum gravity is very complex theory. Earlier, I mentioned that in loop quantum gravity, there are many mathematical theory that you have to clear, like topology, global analysis, algebraic geometry, differential geometry, tensor analysis, functional analysis, non-commutative geometry, group theory, knot theory, etc. So thereafter we saw how in loop quantum gravity singularity is removed by quantization of gravity, and that is why it is also known as quantization of geometry. Thereafter we saw black hole information paradox fundamentals and how loop quantum gravity solves black hole information paradox by giving two theory, remnant scenario and Planck star. Thereafter, we saw fundamentals of big bounce model that we will see in more depth for amateurs, other physicists and laymen in next chapter. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture or any associated concept, you can ask in the comment section. And from next video, we will see another application of loop quantum gravity, that is loop quantum cosmology.